In this lesson, we will examine two ways to measure dispersion. In other words, we will examine ways to measure the degree to which a set of numbers are spread out. The first measurement we will look at is range, and the second is standard deviation. Now, to set the stage here, please consider the following scenario. Let's pretend that you are in your early 20s and you want to take a bus tour somewhere interesting. A travel agent has found a tour that leaves tomorrow and the price has been drastically reduced. However, before you say yes to the tour, you want to learn a little bit more about the other passengers on the tour. So first you ask the agent how many other people are signed up for the tour, and she tells you that 10 people are signed up. Next, since you want to travel with people your own age, you ask for the average age of the other travelers, and the agent tells you that the average age is 22. Now, since you happen to be 22 years old, this sounds like a great trip. The only problem is that there are many possible ways in which 10 people can have an average age of 22 years. For example, all 10 people could be 22 years old, in which case the average age is definitely 22. Or these could be the ages of the 10 people, in which case the average is also 22. We should also recognize that the ages could look something like this, and still have an average of 22. So as you can see, although the average is 22 for all three sets of numbers, the numbers themselves are quite different. So knowing only the average age does not necessarily give us a clear picture of the population. Now, another useful piece of information here would be to know how dispersed the numbers are. One way to measure this is to use the range, which is equal to the largest number in the set minus the smallest number. So for the first set here, the range equals 22 minus 22, which is 0. For the second set, the range equals 26 minus 18, which is 8. And for the last set, the range equals 80 minus 1, which is 79. So as you can see, knowing the average value and the range gives us a better idea of how a certain population looks. Now, it should be noted that the range has certain limitations when it comes to accurately describing a population. To show these limitations, let's continue with our example here. Let's say that the travel agent tells you that in addition to the 10 travelers having an average age of 22 years, the range of ages is 79. Given this information, the ages could look like this, or possibly like this. Both sets of numbers here have an average of 22 and a range of 79, but as you can see, the sets are quite different. So the problem with range is that it only tells us about the extreme values in the set. It doesn't tell us anything about the numbers in the middle. For example, in the first set, the traveler whose age is closest to yours is still 8 years older than you. Conversely, in the second set, there are 6 travelers who are between the ages of 21 and 24. So although range does provide some information about how dispersed the numbers are, we need a measurement that goes beyond telling us the difference between the two extreme values in a set. That's where standard deviation comes in. The standard deviation measures the extent to which each and every number in a set deviates from the mean. Here's how standard deviation is calculated. To find the standard deviation of values from x1 all the way to xm, we will need to know the mean of the values and the total number of values. Once we have this information, the standard deviation, SD, is calculated as follows, where x1, x2, x3, and so on are the individual numbers in the set. So let's use this formula to find the standard deviation of this set of numbers. To do this, we will first calculate the mean, which is 4. And we can see that n, the number of values in the set, is equal to 5. When we plug these values into the formula, we get the following. From here, we can simplify the information in the brackets, and then we'll square each of these values. This simplifies to be the square root of 3.6, which equals approximately 1.9. So the standard deviation of this set of numbers is 1.9. Now, it's very important to know that on the GMAT, you will never be required to use this formula to calculate the standard deviation of a set of numbers. In fact, questions involving standard deviation will typically test your knowledge of what standard deviation measures. Since this is related to the way standard deviation is calculated, let's see if we can get a better idea of how this formula works. To begin, notice that the information inside each bracket here is telling us how far each number in the set is away from the mean. For example, here we are finding the difference between 1, the first number in the set, and the mean, which is 4. When we subtract these values, we get -3. So essentially, the first number, 1, is 3 units away from the mean of 4. Similarly, this -1 here is telling us that the second number in the set, 3, is 1 unit away from the mean of 4. Now, in an effort to handle the various negative numbers that can arise in this formula, we square each difference, which turns them into positive numbers. Once we add these numbers together, we divide this sum by 5. So in essence, we are finding the difference between the mean and each number in the set. Then we square those numbers, and then we find the average of those squares by dividing by 5. Finally, to undo the squaring that we did earlier, we take the square root of everything. From all of this, we can develop an informal definition of standard deviation, which will allow us to forget everything we know about the formal definition. The informal definition says that the standard deviation is the average distance the data values are away from the mean. This definition will be all you need to know to tackle all standard deviation questions on the GMAT. So let's use this definition to find the approximate standard deviation of the numbers we used in the last example. So first, we will calculate the mean of the numbers, which is 4. Now that we know the mean, we can determine the distance that each number is away from the mean. The first number is 1, and it is 3 units away from the mean of 4. The second number is 3, and it is 1 unit away from the mean of 4. The third number is 4, and it is 0 units away from the mean. Next we have 6, which is 2 units away from the mean. And finally we have another 6, which is 2 units away from the mean. Our informal definition says that the standard deviation is the average distance the values are away from the mean. To calculate this average, we will add up the 5 distances and then divide by 5. When we do this, we get a standard deviation of 1.6, which is close to the standard deviation we calculated using the formal definition. However, as I said, you will never be required to calculate the standard deviation of a set of numbers on the GMAT.